Hello students, in our previous class we learned about quadratic equation, its general form and three procedures by which we can solve quadratic equations. Okay, one of the procedure is Sridharacharya's formula. So we learned about Sridharacharya's formula, then how we can solve a quadratic equation by that Sridharacharya's formula. Okay, in this class we will learn how the coefficients of the general form of a quadratic equation are related with the roots or zeros of a quadratic equation. Okay, then we will learn the nature of roots of a quadratic equation. Okay, so let us study how the coefficients of a quadratic equation related with its zeros. Okay, the general form of a quadratic equation is ax square plus bx plus c equals to 0. Where a not equals to 0 and a, b, c are real numbers. By Sridhar Acharya's formula, we have x equals to minus b plus minus root over of b square minus 4ac whole divided by 2a. Okay, already we learned the general form of a quadratic equation is ax square plus bx plus c equals to 0, where the strict condition is a not equals to 0 and a, b, c are real numbers. Okay, and then by Sridharacharya's formula we have x equals to minus b plus minus root over of b square minus 4ac whole divided by 2a. Now two roots of this quadratic equation are minus b plus root over of b square minus 4ac whole divided by 2a and minus b minus root over of b square minus 4ac whole divided by 2a. Taking positive and negative separately, we get these two roots. Let alpha equals to minus b plus root over of b square minus 4ac whole divided by 2a and beta equals to minus b minus root over of b square minus 4ac whole divided by 2a. Now we consider these two roots as alpha and beta. So alpha becomes minus b plus root over of b square minus 4ac whole divided by 2a and beta becomes minus b minus root over of b square minus 4ac whole divided by 2a. Okay. So therefore alpha plus beta is equals to minus b plus root over of b square minus 4ac whole divided by 2a plus minus b minus root over of b square minus 4ac whole divided by 2a. Since their denominators are same, so LCM becomes 2a. And in the numerator, minus b plus root over of b square minus 4ac minus b minus root over of b square minus 4ac. Cancelling these two, root over of b square minus 4ac, we get minus 2b by 2a. Cancelling these two, we get minus b by a. Okay, so alpha plus beta becomes minus b by a, and alpha into beta is equals to minus b plus root over of b square minus 4ac whole divided by 2a into minus b minus root over of b square minus 4ac whole divided by 2a. So these are two fractions. Like the product of two fractions, we have this equals to product of the numerators divided by product of the denominators. Okay, so the product becomes minus b plus root over of b square minus 4ac into this whole into minus b minus root over of b square minus 4ac whole divided by 2a into 2a. Now these two are like p plus q into p minus q. Okay, now these two are like p plus q into p minus q. Here p means minus b and q means root over of b square minus 4ac. So by this identity we can write minus b whole square minus root over of b square minus 4ac whole square, and in the denominator 4a square. Okay, so minus b whole square means plus b square, and whole square of root over of b square minus 4ac will give b square minus 4ac whole divided by 4a square. So the numerator becomes b square minus b square plus 4ac whole divided by 4a square. Cancelling these two b squares, we get 4ac by 4a square. Cancelling 4a from numerator and denominator, we get c by a. So alpha plus beta, that is sum of the roots, becomes minus b by a, and alpha into beta, that is product of the roots, becomes c by a. So now ax square plus bx plus c equals to 0 imply 1 by a into ax square plus bx plus c equals to 0. Since a not equals to 0, therefore we can multiply both sides by 1 by a. Okay. So after multiplication with 1 by a, we get 1 by a into ax square plus bx by a plus c by a equals to 0. And in the right hand side, 1 by a into 0 means 0. Cancelling this a, we get x square. We can write this plus b by a as minus into minus b by a. This whole into x plus c by a equals to 0. We represent this plus bx by a as minus of minus b by a into x. So minus b by a is equals to alpha plus beta, and alpha into beta is equals to c by a. Okay, that is why we can replace this minus b by a by alpha plus beta and this c by a by alpha into beta. Okay, so this is the, now this represents the quadratic equation when roots are alpha and beta. Okay, so this is the form by which we can find the quadratic equation when its roots are known. Roots are known means the sum of the roots and product of the roots are basically known. Okay. Here we choose a problem. Okay. So in this problem, alpha and beta are the roots of a quadratic equation where alpha and beta are related by these two relations, that is alpha square plus beta square equals to 9 and alpha into beta equals to 8. We have to find the quadratic equation. Okay, so since alpha and beta are the roots of this quadratic equation, so to find this equation we have to know sum of the roots and product of the roots. Okay, that is why first of all we have to find alpha plus beta, and here alpha into beta is already given. So after finding alpha plus beta, we can use this formula. Solution given alpha square plus beta square equals to 9. Alpha into beta equals to 8, where alpha and beta are the roots of the required quadratic equation. Okay. So now alpha square plus beta square equals to 9 imply alpha plus beta whole square minus 2 alpha beta equals to 9. Since p square plus q square equals to p plus q whole square minus 2pq. So by this identity, p square plus q square equals to p plus q whole square minus 2pq, we can represent this alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta. Okay. So this imply alpha plus beta whole square minus 2 into alpha into beta means 8. 2 into 8 equals to 9. This imply alpha plus beta whole square equals to alpha plus beta whole square minus 16 equals to 9. This imply alpha plus beta whole square equals to 9 plus 16. This imply alpha plus beta whole square equals to 25. So this imply alpha plus beta equals to plus minus 5, because plus 5 whole square is 25 and minus 5 whole square is also 25. That is why alpha plus beta is equals to 5. Okay, plus minus 5. Here alpha into beta equals to 8. So alpha and beta both may be positive or negative. That is why we have to take alpha plus beta equals to plus minus 5. Okay. Since the product of these two roots, that is alpha into beta equals to 8, so alpha and beta both will have same sign. That means alpha and beta both may be positive or both may be negative. That is why we have to choose both values of alpha beta. That is alpha beta is equals to plus 5 and minus 5 also. Okay. So the required quadratic equation are equations are x square minus of alpha plus beta whole into x plus alpha beta equals to 0, imply x square minus of plus minus 5 whole into x plus 8 equals to 0. This imply x square plus minus 5x plus 8 equals to 0. Okay. So we have two different quadratic equations by these given conditions. Okay. So the quadratic equations are x square plus 5x plus 8 equals to 0, or x square minus 5x plus 8 equals to 0, or x square plus 5x plus 8 equals to 0, and x square minus 5x plus 8 equals to 0. So this is the way by which we can find a quadratic equation when its zeros are related by some conditions, and from those given conditions, first of all we have to find sum of the roots and product of the roots. If they are not given, Then after finding those roots, those conditions, that is alpha plus beta and alpha into beta, we can find the quadratic equation by using this formula. Okay. Now we will learn the nature of roots of a quadratic equation. Okay. So when ax square plus bx plus c equals to 0, where a not equals to 0 represents a quadratic equation, then by Sridhar Acharya's formula, we have x equals to minus b plus minus root over of b square minus 4ac whole divided by 2a. Okay. Already we know this formula. Here b square minus 4ac is known as discriminant denoted by capital D. Okay. This factor b square minus 4ac is known as discriminant denoted by capital D. The nature of roots. Nature of root means what will be the type of the roots. That means that root may be rational or irrational or equal or imaginary. Okay. So these are some types of roots. Okay. Now we will learn what are the conditions by which we can distinguish a root with the help of discriminant, or we can say this is the way by which we can identify a root of a quadratic equation. That root may be rational, irrational, equal or imaginary. Okay. Nature of roots of a quadratic equation. When number 1, when d equals to 0, then the roots are equal. That is, when discriminant of a quadratic equation is 0, then the roots are equal. Okay. Because if we put this thing b square minus 4ac equals to 0, then x will be equals to minus b by 2a. That means the values of both the roots will be minus b by 2a. Number 2, when d greater than 0, and a perfect square term, then roots are real, rational and unequal. When d equals to 0, then roots are real, roots are equal and real. Okay. So when d is greater than 0 and a perfect square term means the term which can be expressed by the square of other term. Like perfect square terms are like 16, as perfect square terms are 16, 25, 144, etc. As 16 equals to 4 square, 25 equals to 5 square, 144 equals to 12 square. Okay. So perfect square term means the term or the terms which can be expressed by the square of another term. Okay. Like 16 means 4 square, 25 means 5 square, 144 means 12 square. That is why they are the perfect square terms. Number 3, when d greater than 0 but not a perfect square term, then roots are real, irrational and distinct, that is unequal. Okay. So when d is greater than 0 but not a perfect square term, then roots are real, irrational and distinct. Okay. Irrational means there will be some square root term like root 2, root 3, root of 65, etc. Okay. They are the irrational numbers. So these kind of numbers will be present in the roots when discriminant d is not a perfect square term. Number 4, when d is lesser than 0, then the roots are imaginary. Okay, so when discriminant d becomes lesser than 0, then the roots are imaginary. Okay, in this class we will learn about the real roots, and those roots may be equal, may be rational and unequal, may be irrational and unequal. Okay, in after some classes, when we learn about complex number, then we will learn how the imaginary roots help us to find a quadratic equation. Okay, so these are the natures of roots of a quadratic equation. So we can identify the nature of roots of a quadratic equation when discriminant is known, and depending upon the nature of the discriminant, we can identify the nature of roots of a quadratic equation. Okay, here we choose a problem. In this problem we have to find the value or values of k for which this quadratic equation will give equal roots. Okay, already we know already we know from the nature of roots, when discriminant of a quadratic equation becomes equal to 0, then its roots are equal. Okay, so let us study how we can find the value of k. Given quadratic equation is k minus 12 whole into x square plus 2 into k minus 12 whole into x plus 2 equals to 0. Comparing the given equation with the general form of quadratic equation ax square plus bx plus c equals to 0, we get a equals to k minus 12, b equals to 2 into k minus 12, and c equals to 2. Since the roots of the given quadratic equation are equal, therefore d equals to 0. D means b square minus 4ac. So b square minus 4ac equals to 0, imply 2 into k minus 12 whole square minus 4 into k minus 12 into 2 equals to 0. So 2 into k minus 12 whole square will give 4 into k minus 12 whole square minus 8 into k minus 12 equals to 0. 4 to the 8, so 8 into k minus 12 equals to 0. Now from these two terms, 4 into k minus 12 whole square and 8 into k minus 12, the common factor is 4 into k minus 12. The rest of the terms becomes k minus 12 minus 4 to the 8 minus 2 equals to 0. This imply k minus 12 into k minus 14 equals to 0 by 4. Okay. This 4 when goes in the right hand side, then this will be divided from, that is why k minus 12 into k minus 14 equals to 0 by 4. So this imply k minus 12 into k minus 14 equals to 0. Now product of these two terms equals to 0. So this imply k minus 12 equals to 0 or k minus 14 equals to 0. So product of these two terms equals to 0 means both of these equals to 0 or one of these equals to 0. Okay. So since we don't know which one of these is equals to 0, that is why we have to choose both of these equals to 0. That means this equals to 0 or this equals to 0. So this imply k equals to 12. Again, if k minus 12 equals to 0, then so k minus 12 equals to 0 or k minus 14 equals to 0. But if k minus 12 equals to 0, then this given quadratic equation will not give a quadratic equation because this square term will remove. Okay. So that is why we can write, but k minus 12 not equals to 0 as the given equation is quadratic, as the given equation is quadratic. Okay. So when k minus 12 equals to 0, then this will not be a quadratic equation. Okay. That is why we have to choose only k minus 14 equals to 0. So therefore k minus 14 equals to 0 imply k equals to 14. Okay. So the given quadratic equation will give equal roots only when k equals to 14. So this is the way by which we can use the concept of nature of roots of a quadratic equation. Okay. In our previous in upcoming class, we will learn how we can solve more problems of quadratic equation but with the help of nature of roots. Okay.